In this lesson, we are going to be solving word problems that involve right triangles and trig functions. For some word problems, you might have to know the difference between the angle of elevation and the angle of depression. The angle of elevation, you can think about it if you are looking straight ahead and then you look up. That is the angle of elevation. So from your line of sight directly out and then looking up towards something, that angle in there is the angle of elevation. The angle of depression is if you're looking straight out and then you look down at something, that angle is the angle of depression. So the first word problem that we're going to look at. Darren works on a road construction crew. He is able to measure the angle of elevation using an instrument called a theodolite. The angle of elevation from one point to another is 9 degrees. The slope distance between the 2 points is 250 meters. How much does the road rise? Does the road rise over that distance? So what we want to do is draw a diagram of this situation. Okay, so here's our diagram. So we have the angle of elevation. Again, if you're standing here, you would look straight out and then you would be looking up. So our angle of elevation is this angle here at 9 degrees. And then the slope distance is going to be the slanted part of this road. Okay, so the slope distance is 250 meters. So the slanted part of the road is 250 meters. The question is asking how much does the road rise over the distance? So this is what we're looking for here. How much is the road rising from 0 degrees up to the top of the 9-degree angle? Okay, so we are going to use our trig ratios for this. So again, the first thing that we need to do is label our triangle. So we have our 90-degree angle. Directly across from the 90-degree angle is the hypotenuse. Then we are working with the 9-degree angle. So directly across from that is the opposite side. And then that third side is the adjacent side. So again, we want to choose the two sides that are going to give us information. So the hypotenuse has the 250 meters. The opposite side has our x value. Our adjacent side doesn't have any information, so we're not using the adjacent side. So again, we're going to look at SOHCAHTOA and figure out which one of the three trig ratios we're going to use, either sine, cosine, or tangent. So in this example, we've got the opposite side and the hypotenuse. So O and H, we look at the three different pieces of SOHCAHTOA, and the O and the H is the first part with the SO. That tells us that we're going to be using our sine ratio, and we've got the sine of the angle that we're working with. So sine of 9 degrees equals the opposite side of x over the hypotenuse of 250 meters. So to calculate this, we're going to figure out what sine of 9 is. Type that into your calculator. And we get 0.1564 equals x over 250. We're going to put a 1 underneath of our decimal, and then we're going to cross multiply. So we'll have 1 times x is x, and then multiply our two other numbers, and we will get 39.1 meters. We know that it's meters because there's meters in the question. So 39.1 meters is how much the road rises. Looking at the next example, a telephone pole is diagonally braced by a piece of timber 6.8 feet long. The angle between the pole and the timber is 34 degrees. How high up the pole does the timber reach? So the first thing that you want to do with this is create a diagram. So here's the diagram that we can work with. So we have our telephone pole. That's the vertical line. We know that the angle between the pole and the timber is 34 degrees. So that's this angle right here. So our telephone pole and the support wood is there. And then it says that the telephone pole is diagonally braced by a piece of timber 6.8 feet long. So this piece here that's on the angle is 6.8 feet. And we want to know how high up the pole does the timber reach. So we're looking for this side here. So from this point to the bottom is the distance that we're looking for. So again, we want to label our triangle so we know, so we can figure out whether we're using sine, cosine, or tangent. So here's our 90-degree angle. So directly across from that is our hypotenuse. Then the angle that we're working with, directly across from that is the opposite side. And then the x is in the adjacent position. So now we're going to refer to our SOHCAHTOA again. And again, we want two of the three sides that have information on them. So the adjacent side has our x that we are looking for. The hypotenuse has the 6.8, and our opposite side doesn't have any information, so we're not using that opposite side. So just the adjacent and the hypotenuse. So referring to SOHCAHTOA, which one of the three has an A and an H in it? It's the ka part. So that tells us that we're going to be working with cosine. So we'll have cosine of our angle of 34 degrees equals the adjacent side over the hypotenuse. So our adjacent side is x and our hypotenuse is 6.8. So calculate our cosine of 34. We'll get 0.8290 equals x over 6.8. We're going to put a 1 underneath of our decimal, and then we're going to cross multiply. So we'll have 1 times x is x, and then we'll multiply 0.8290 times 6.8. And when we do that, we will get an answer of 5.6, and this time we're using feet. So 5.6 feet is the distance from the bottom of the telephone pole to where the brace piece of wood meets it. Okay, the last example that we're looking at says, near Prince Albert, Mary and James like to lie on their backs in an open field to watch planes land. One day, as they watch, a helicopter approaches and hovers over a building 1 kilometer away. 1 kilometer away from them. If the angle of elevation is 25 degrees, how high above the ground is the helicopter? So again, we want to draw a diagram of this. So in this diagram, this is where Mary and James would be lying on their back in a field. Okay, so these are the two people right here. Okay, 1 kilometer away is where the helicopter is hovering above this building. So that's our 1 kilometer along the ground. We know that the angle of elevation is 25 degrees. So that's going to be from the people, and they're going to be looking up at the helicopter. So our angle of elevation is this angle with 25 degrees. And what we're looking for in the question is how high above the ground is the helicopter? So we're looking for the height of the helicopter over here. So for this one, just like the others, we need to label our triangle. So we've got our 90-degree angle. Across from that is our hypotenuse. Then we go to the angle that we're working with, the 25-degree angle. Across from that is the opposite side. And then that third side is our adjacent side. So now we want to know which two sides have information for us. So the opposite side has the x, the adjacent side has the 1 kilometer. The hypotenuse doesn't have any information, so we're not using the hypotenuse. So we're going to look at SOHCAHTOA to figure out which one of the 3 trig ratios we're going to be using. So we've got the opposite side and the adjacent side. So that's going to relate to the TOA part, so opposite and adjacent. So that tells us we're going to be using our tan ratio. So we're going to have tan of the angle we're working with, so tan of 25 degrees equals our opposite side of x over our adjacent side of 1. So we want to figure out tan 25 is going to be 0.4663 equals x over 1. And I'm going to put a 1 under our decimal. And now we can cross multiply. So we'll have 1 times x is x. And then 0.4663 times 1 is going to be 0.4663. But we're going to round this to 1 decimal place. So we will get 0. The 6 is going to bump the 4 up to a 5. So 0.5 kilometers. So that tells us that the helicopter is half a kilometer above the ground.